My name is Narsafa Atia binti Shahabuddin.
Hi, my name is Anjutin.
Hello, my name is Vivian Lee Hui Lee.
Following the theme EMT in biomedical devices, our project focused on ultravision electrostatic precipitator, which is a biomedical device used in operating rooms. The specific EMT concept applied is the electric field, governed by Coulomb's law, which explains how oppositely charged particles interact.
So now let's start with our demonstration. At first, you need to prepare all the materials that are needed, which are wire with crocodile, alligator and clip, high voltage generator which is 1000 kilovolt, power supply, needles, sink filters, aluminium foils, chopsticks, tape, lighter, incense, and also clear plastic Tupperware. So now we need to make sure that the high voltage generator is functioning. So at first, you need to cut the bottom of the clear container by using a blade. Then you need to put the sink filter inside the hole. Then you need to wrap the aluminium foil around the top of the clear container. Then we need to use the chopsticks, which is cut into half, as a stand, then combine it using the black tape. So this is how the connections looks like. The positive charge of the power supply is connected to the discharge switch, which is the red color wires of high voltage generator, while the negative charge will connect to the green color wires, while the discharge terminal, which are the golden wires, are connected to the crocodile clips, which are then connected to the top of the container and also the bottom of the container, while the red crocodile clips will clip at the bottom of the container, which is connected with the sink filters, which will act as the metal mesh, while the other hand, the black color crocodile clips were connected to the aluminium foil, which acts as the positive charge, while the bottom of the container will act as the negative charge. So when we light up the incense and put it at the bottom of the sink filters, the smoke will pass through. So when the power supply is turned off, the smoke simply flows through it. So when the power supply is turned on, the outlet is clear of any visible smoke. Now, for our next demonstration setup, which is we use the container as our human's cavity. At first, we use the needle to make two small holes at the bottom of the plastic container. Then we wrap aluminium foil around the container's lid to act as the collector plate. Next, we place an incense stick and one of the needles into the two holes respectively, while the incense will generate smoke and the needle will act as the high voltage emitter. So for the wiring part, we connected the black crocodile clip, which is the negative terminal, to the needle, and the red crocodile clip, which is the positive terminal, to the aluminium foil. The working principle is the same as mentioned earlier. If the power supply is turned off, the smoke will accumulate inside the container, but when we turn on the power supply, the container or the cavity becomes visibly clearer. This is because the smoke particles are charged by the electric field and are attracted to the foil, effectively removing them from the air.
The first one is the high voltage needle. The needle connected to the ion generator, and the sharp tip of the needle will ionize the smoke particles with negative charges, according to the electric field theory. As a result, the smoke particle become negatively charged. Now, the smoke particle will experience an electrostatic force with a less negatively charged surface on the plate, and the plate will safely collects and grounds accumulates. The particle settles on the ground and accumulates the conservation of charge as described by Gauss's law. So now is the principle of ultravision. Ultravision is the electrostatic precipitation for surgical smoke removal. So how we relate it to the electrostatic theory? First, we use the Coulomb's law that shows the interaction between the ionized smoke. We use the formula of F equal to K dot Q1 dot Q2 over R square, where F is the electrostatic force, K stands for Coulomb's constant, Q1 and Q2 is the charge on needle and smoke particles, and R is the distance between the needles and also the smoke particles. So the key point here is the more and closer charge between needles and smoke, the stronger the force between them. The second one is the electric field E. We use the formula of E equal to V over D, where V is the voltage that we use 6 to 12 volt, and for the distance is the distance between the needle and also the plate. So the key point here is the stronger the field, the greater the attraction between the smoke particles to the plate. For the application of ultravision system, mainly in minimally invasive surgery. It has advanced visualization, unmatched bioaerosol control, and minimization of workflow disruption from surgical smoke management are all provided by ultravision. Other than that, ultravision also provides patients with the ability to maintain a stable normal peritoneum during both standard and low pressure operations while reducing patient carbon dioxide exposure.
This principle allowed the device to capture harmful surgical smoke through electrostatic attraction, ensuring a clearer and safer surgical environment. Instead of mechanical filtration, this device leverages electromagnetic field theory to remove airborne contaminants, demonstrating how physics directly improve biomedical safety and precision.